is an extremely accurate and versatile piece of navigational gear that can tell you at any instant right where you are and how to get where you are going. In this film, I'm going to introduce you to the parts of the INS as used in American's 707 and tell you a bit about how they do their job. There are three components to a system. The control display unit that we normally call by its initials CDU, and the mode selector unit, or MSU, plus the inertial navigation unit in lower 41. Now here's where the INS senses aircraft movement and does its arithmetic to give you the exact navigational information you want. In this unit are highly sensitive accelerometers that detect any change in aircraft motion and send out an electrical signal to tell about it. Enclosed within each accelerometer is a metal weight floating in a special dense liquid so that the weight has neutral buoyancy. In other words, it won't rise or sink of its own accord, but is freely suspended by the fluid. When the accelerometer is moved, the weight will resist the moving force and react like a pendulum, swinging toward one end of the case and activating an electrical signal that's proportional to the force. Because these accelerometers respond to movements back and forth along only one line, one accelerometer is lined up to sense forward motion, while another is lined up to sense any turns. The inertial platform on which the accelerometers are mounted is stabilized by two electrically driven gyros that are controlled by the computer to hold the platform level with the Earth's surface at all times, automatically correcting the platform's position to compensate for the Earth's rotation, for the fact that the plane is traveling over a round surface, not a flat one, as it flies, and for a number of other conditions that would otherwise upset the leveling of the platform. As a result, the signals from the accelerometers represent a precise indication of the aircraft's travels over the surface of the Earth. These signals are transmitted to the INS computer. Then, because you've already fed in the latitude and longitude of your point of departure, it's a snap for the computer to continuously calculate your geographic position moment by moment. In addition, you can use your control display unit, or CDU, to ask the computer to figure the actual track you're making good over the ground and your ground speed along that track. You can also ask for your true heading and the drift angle between this heading and your actual track. This switch position tells you the distance and time to your destination, or to your next checkpoint, which we call waypoints. Or you can get the direction and velocity of the wind you're flying in by using this switch position. We'll talk more about this switch and its uses in a later program. To feed numerical information into the computer, you simply press these buttons just like you'd put a figure into an adding machine. A quick check for accuracy, and then the data is inserted into the computer's memory bank. The mode selector unit, or MSU, is used to energize and align the system before flight, and to select in-flight operational modes that will give full navigational functions, or will give only attitude reference information from the gyros on the inertial platform. American 707s have two inertial navigation systems aboard, one for the captain and one for the first officer. Both systems are complete and independent, including individual normal power supplies from separate AC buses for each system, plus DC power and battery backup supply circuits. Together, the two inertial navigation systems add only a little over 100 pounds to the weight of the plane, and they'll work for you in many ways. right from the time you leave the ramp until you touch down at your destination.